Okay, we have one more thing to look at here, and we're not even going to look at all of it. I really just want to look at that first part. So the function g is defined and differentiable on the closed interval -7 to 5 and satisfies g of 0 is equal to 5. The graph of y equals g prime of x, the derivative of g consists of a semicircle and 3 line segments as shown in the figure above. So we want to find g of 3 and g of -2. So in order to find these values, I need to find the integral because I have the derivative function. So we have g of 3 is equal to. One thing that we want to keep in mind here is that we have an initial condition. So our derivative takes care of what's happening in that interval. So it's looking at what's the area over this interval, but it's not saying, hey, we started at this point, so we're going to add that to our interval. So whenever we have an integral like this, we want to take the solid point that they told us, which would be g of 0, and we want to put that into our problem. So we have g of 0 plus the integral from, that's now our starting point. So we're going to start from 0 to 3 of g prime of x. So we have 0 to 3 g prime of x plus g of 0. G of 0 they gave to us, so it's 5 plus. So 0 to 3, we're looking between this right here and this halfway piece here. So what we're looking at is this triangle area. So we're going to use the area of a triangle, and we have this quarter of a circle. And I know it's a quarter of a circle because they told us we have a semicircle, and it's half of that. So things that we want to know about our semicircle is the radius, because this is the center, is 2. So we're going to use the equation for a circle to find the area. So we want pi r squared, and then we're going to divide it by 4 because we only want a quarter of that circle. So pi times our radius, which is 2, squared divided by 4, plus. And then we need the area of this triangle. So we have a base of 1, and we have a height of 3. So we're going to use the area of a triangle formula. So 1/2 base times height. So now we're going to simplify what we have here. So we have 5 plus 2 squared is 4. 4 divided by 4 is 1. So we have pi. 1 times 3 is 3. Divided by 2 is 3/2. So we have pi plus 3/2 plus 5. We can combine the 5 and 3/2. 5 in halves is 10/2. So we have 13/2 plus pi. So g of 3 is 13/2 plus pi. We're going to do the exact same thing, but for g of -2. So we have g of -2 is equal to g of 0, because that's the only point that we know for sure. And we're not going to use g of 3 now, because that's going to give us a weird value in between. Plus the integral from 0 is our starting point, so we always want to start with 0 at the bottom, no matter what our other value is. So 0 to -2, g prime of x dx. So the one thing that we want to do here to kind of help us out is we want to change that integral. So one of the things we learned earlier is that if I switch the interval, so I want to go from -2 to 0, g prime of x dx, I just need to now subtract. Either way, we're going to get a negative for our pieces here, because if I go from 0 to -2, we're going in that negative direction, so our area would have been negative anyways. But we need to be a little bit careful. It's easier to always start at the lower number to go to the higher number. If our area is above the y-axis, then it's going to be positive. If it's below the x-axis, it's going to be negative. So when we kind of switch that interval around, it just adds a little bit more to our problem. So we know g of 0 is 5. And we also know from -2 to 0, we're looking at that semicircle again, but just a quarter of it. And we already know that that semicircle's area is pi because we already did all the work for that. So I know that g of 2 would be 5 minus pi.